my work is synthesize characterization of bio-based polyols and assess effectiveness of bio-based polyurethane direct to metal coating system. Uh, right. Right now, I'm going to give a little description about the paint. Paint is a mixture of chemicals. These are the main components can be found in the paint mixture. Number one is pigment. Pigment gives the color and strength of the film build, and the binder. Bind is just like a gum. It gives a addition property, and solvent is a colorless water or hydrocarbon or any other ketones aldehydes let's like materials comes under solvents. Then additives are specialty chemicals depending on the paints. So wetting agents, it reduces the surface tension. If the surface tension is very high, it is very difficult to mix with materials, pigments and binders and solvents. So we have to reduce the surface tension. So therefore, we are putting some wetting agents to do that thing. Then dispersing agents to grind the pigment. Pigment is normally pigments are uh, some big particles. We need to reduce them up to certain micrometers. Therefore, grinding efficiency we have to improve. Therefore, we are putting some dispersing agents to get that property. Then the thickness. Now you can see this paint is not sagging because it's just like a thick paste. So increase the thickness. So we are put thickness. So the other thing is UV stabilizers to uh, sun's light can deteriorate the color. So UV stabilizers make a resistance to sun's UV light. So deformers you are normally putting to may reduce bubbles coming out from the paint stuff. Yeah, the next slide. Okay, the paints use based on end users we can divide into two: decorative coatings and the industrial coatings. Decorative coatings normally we are doing our paint works in our houses, emulsion paints, enamel paints, wood coatings. They are coming under decorative coatings, but industrial coatings are high performance. They are completely different with most of the time our home painting system. Now here you can see automotive coatings, cars, vehicles uh, uh, coming under these automotive coatings, and marine coatings, ships, submarines, like huge vehicles coming under marine coatings, powder coating, road marking, coil coatings, aerospace coatings. These are different coatings coming under industrial coatings. Main mechanisms used to minimize crude oil based substances in my research. I have used two different strategies to minimize crude oil based materials in the paint formula. Number one is direct to metal coating system, and the number two is uh, crude oil based material I replaced from coconut oil. Briefly, I'm going to introduce these things. Next slide. Right here we can see direct to metal coating system. Right now, normally classical industrial coating system. This is just like we are going to use our. We are going to paint our vehicle. This classical industrial coating consists with three, at least three layers. Number one, you can see the vehicle brown color one. That means metal primer sprayed on top of the bare metal, right? After on top of primer, we have to apply filler coat. On top of the filler, we have to apply a top coat, final coat. So the ultimately final coat gives the aesthetic appearance of the vehicle. But direct to metal, we don't need any metal coat or we don't need any primer coat. Directly, we can apply the paint on top of the bare metal. That is the thing of direct to metal industrial coating. Environmental impact comparison we can see here. In the classical industrial coating, the primer comes through three packs: base, component, and hardener and thinner. Three cans we have to use. In filler also it contains three cans, and top coat also contains it a three cans. So ultimately when you finish your vehicle painting, you have to remove nine cans. These are most of the time contaminate our environment. But direct to metal coating, we use only three cans: base, component, hardener, and the thinner. So now you can see one third. Ultimately, we have to left over only three cans here, right? So the hazardous materials 66% already cut down by DTM, that means direct to metal coating system. And the contaminated cotton rugs, when you do a one coating, let's say primer, after the primer we have to clean our utensils. So therefore we use some cotton rugs. Let's say the cotton rugs weightage is X, but direct to metal it X divided by 3. That means one third of waste materials we have to uh, save. We have to save a lot of materials. Contaminations are very low, and volatile materials also. Let's say this is X, this is X divided by 3. 66% volatile materials we can save our environment it by using direct to metal coating system. All right, okay. The second modification is eco-friendly modification. Now you can see in the direct to metal paint system, it has three cans. Number one is base paint and the hardener and thinner. The mixing ratios of these paints: 100 parts of base paint and 50 parts of hardener and 20 parts of thinner. Right. I modified the now principal components in these cans. The base paint contain the main component is crude oil base polyol. The hardener is isocyanate, and thinner is a mixture of solvent which are refined by crude oil. So my modification, I used to modify this base paint while eliminating, substituting the crude oil based material by using coconut oil based polyol. Right. Here is my methodology: synthesizing bio-based polyol. I am starting from. I have already started from coconut oil. Coconut oil made out of triglycerides. Now, in this triglyceride, I need to remove two fatty acids. So that process we call monoglyceride pathway. In the monoglyceride pathway, I used glycerine to remove this excess to fatty acid, and finally it end up with monoglyceride. Monoglyceride contains only one fatty acid in the this structure. Therefore, two OH groups are freely available to modify. In this slide, you can see this is the triglyceride. The left hand side corner in the polymer, you can see the triglyceride, and I have to add. I already put pentaerythritol and phthalic anhydride to modify my polymer. This bio-based polymer then mixed with pigments and other paint materials, and finally I obtain the PU paint. I have produced series of PU paint based on biomaterials. In this series, I have chosen the most useful and in property wise the best one to compete with commercially available uh, crude oil based PU paints in the market. Now here I have made some PU paints by use of commercially available PU resins. So finally, I already competed these biological based PU and artificial crude oil based PU. Right. Here is the modification. So this is the oil analysis of the coconut oil. Right now you can see the average molecular weight of coconut oil, 213.232, and the number of moles present in 100 grams of coconut oil of all the fatty acids in the coconut oil. It is about 0.4814. Total fatty acid moles in 100 grams of coconut oil is 0.4814 moles. Right now, in my bio-based polymer, I have used 20 grams of coconut oil for this modification. So 20 grams means 0.0963 moles of fatty acids available in that 20 grams of coconut oil. So according to that, I have found total triglyceride molecules in moles in the 20 grams of coconut oil divided by 3.0321. Here is the formula. You can see chemical reaction between triglyceride and two glycerols react together. It forms three monoglyceride molecules. So if you got 0.321 moles of triglycerides, that is the available triglyceride moles in 20 grams of coconut oils, you require 0.0642 moles of glycerol to make monoglyceride molecules. Right. Next slide. So lithium hydroxide I used as the catalyst of this reaction. Right, here is the reactor. You can see the color photograph of the reactor I have worked. Here is the bio-based formula of the bio-based polymer I have made. Right, coconut oil 20, glycerine 5.9, lithium hydroxide, xylene, thallic anhydride, uh, pentaerythritol, and benzoic acid. Right. Now, before cook this resin, I have to find out whether the gelling process is happen or not, because when gelling happens, it is very difficult to remove from the reactor. So therefore, going through a theoretical calculation to find out what is the extent of reaction uh, in my reaction. This is P. P is the extent of reaction. This is coming under Carruthers equation. According to Carruthers equations, I got the answer is 105% 0.4. That means if it exceeds 100%, we don't need to fear because no gelling take place during the cooking. So anyway, in my calculation, I found my value exceeded the 100%. Therefore, I have no fear. I have done my experiment well, and I modified the coconut oil base uh, polyol by using this method. Right now, you can see bio-based PU coatings. Here is the PU coating formulations I have synthesized. There are 5 PQRST are the 5 different uh, PU based direct to metal coatings. The main difference is I have changed the amount of bio based polyol here. This is 50%, this is 55, 60, 65, and 70. Likewise, gradually I have increased the amount of bio based polyol, and finally I checked the properties of these 5. Ultimately, I have found Q is the better among these other things. So therefore, I uh, may use Q biological based PU coating system to compete with commercially available crude oil based PU systems. Right. Q is the better according to my test results. Next slide. Right. Now, bio-based versus crude oil-based PU formulations. So Q is the bio-based PU formulation, and L and M. L and M I was taken from the market, outside market, and test with my biological base PU. A, here you can see this is biological bio-based polyol 55%. Polymer A. Polymer A is Cetal 84XX70. The resin is manufactured by Alnex Thailand. Polymer B, right? Here it is polymer B. Polymer B is macranyl uh, SM510N-60G LG. That is also Alnex Thailand resin. So commercially available resins and biological resins get together and competed. I will show what are the results obtained by me. Right. Now you can see normally in direct to metal chemistry is failed in the market because of the aesthetic appearance is not well. Glossy is very poor. Therefore, people are not like to buy this. So, but in this my findings, can you see there's a pink color line, the gloss level 93.9 relative to other commercially available. When we compare the commercially available ones also have the same. So therefore I increase my gloss level. Normally the market market available now, they are most of these things are equal biologically modified one, and the market available crude oil based PU systems are have equal properties according to these values. Here, touch drying time, right? Hard drying time, the slight difference is there, but our one is relatively best when we compare with L. L is 7 hours, but our one is 4 hours. That means our one is rapidly dry. It is good thing. So the painters can do their painting work very fastly, right? Likewise, uh, pencil hardness, both all these three have same in pencil hardness, impact resistance, mineral blending test, all are equal. My conclusion: flexibility. When we think about the flexibility in the here I can here you can see a thermogram in DSC thermogram. According to the DSC thermogram, we can see the TG, glass transition temperature, in minus side. Therefore, we can say the flexibility is very good, right? The conclusion, number two, the water immersion. Now, water immersion, when we compare with commercially available crude oil based PU systems, our one slight behind with them. So we have to improve the water immersion property uh, relative to commercially available crude oil PU systems. Number three, in Lobibon tinted tintometer value, in coconut oil based polyol, it has a slight yellow color, but crude oil based polyols, they are water white. So there is a little disadvantage comes because of the yellow color, right? Now, in the last conclusion, I finalize here: addition, gloss, impact resistance, drying time, film hardness, film thickness, and flexibility. These properties are equal with commercially available crude oil based mm, resins. They are PU systems. Therefore, we have a good journey in future. to biological based PU systems, direct to metal systems, we can compete with commercially available crude oil based paints. Right. The future, if any person need to develop or further improve this thing, here are the 3 points I have highlighted. Number one is I have used here 20% coconut oil to polyol, biological based polyol, but any person need to improve this, he or she can increase this from 20% to some extent. Likewise, biological based PU system, I have used coconut oil modified resin 55%. So therefore, anyone need to develop further, so he or she can increase this 55% furthermore. And the other thing is, uh, the most hazardous part in this PU system is the middle can. You can see a short can in the middle in the picture, that is harden. Harden is made out of isocyanide, right? If any person to may turn the greenness of this paint system, he has to modify this, right? It's a very big thing. I think I can't say nobody can do this. If any person tries, he or she can do this. That is the major challenge, because PU I have used because that is the most versatile and most popular coating systems among industrial coatings. Right. That is end of my lecture. Thank you very much to listen.